The radius of a circle is increasing at the rate of 3 centimeter per second. So given t is given, radius is given, that is r. So we have been given dr dt equals 3 centimeter per second. Find the rate at which the area of the circle is increasing. Here area of the circle is increasing. We have to find the derivative of the area with respect to time only. So we have to find dA dt. Fine. We have area equals pi r square. So dA dr equals 2 pi r. Why we are doing this? For using chain rule, we require this. How to establish the chain rule? Time increases radius, which increases the area. Therefore, the chain rule is dr dt multiplied by dA dr, which gives us dA dt. Fine. So we have dA dr as 2 pi r, dr dt as 3, which is equal to 6 pi r. That is rate of change of area with respect to time. When r is 10 centimeter, substitute r with 10, substitute 10 with r, sorry, you get 60 pi, since its area centimeter square per second. This is the answer. So how simple it is. If you know the concept, you can just solve the question in under 1 minute. See again, edge we call it as A of a variable cube increasing at the rate of 3 centimeter per second. Again T. So given as dA dt equals 3 centimeter per second. How fast is the volume? So whenever T is given, we have to find dV dt only. So volume with respect to A, V equals A cube, dV dA is 3A square. And let's establish the chain rule. Time increases the edge increases the volume. Therefore, the derivative is using the chain rule dA dt multiplied by dV dA equals dV dt. dA dt is 3 multiplied by dV dA is 3A square, which is 9A square. When A is 10, we have dV dt as 9 times 10 square, which is 900 volume of the cube, no? So centimeter cube per second. This is the answer. The next question. A stone is dropped into a quiet lake and waves moves in circles. So imagine when you drop a stone and the waves moves in the form of a circle, means that the length of the wave from the circle is radius. So we can call this as radius r, and second t is given. Therefore we have dr dt equals 5 centimeter per second. Find the instant when radius of the circular wave. When radius is 8, how fast is the enclosed area increasing? Whenever time is involved, you have to find dA with respect to dt only. Fine. So, as usual, we will see area of circle A equals pi r square, dA dr equals 2 pi r, and we'll establish the chain rule. Time increases or pushes radius, which pushes the area. Therefore, the derivative using chain rule is dr dt multiplied by dA dr, which equals dA dt. dr dt is 5 multiplied by dA dr is 2 pi r, 2 pi r, which is 10 pi r. dA dt is 10 pi r. When r equals 8, we have the answer as 80 pi centimeter square per second. This is the answer. Next question. The radius of a circle is increasing at the rate of 0.7 centimeter per second. Again, T is given, R is given, dr dt equals 0.7 centimeter per second. So what is the rate of increase of its circumference? What is the circumference also? We have to find the derivative of circumference with respect to time only. So we have to find, let's call it as C dc dt. So what is C? 2 pi r. So dc dr is 2 pi. Then let's establish the chain rule. Time pushes radius, that pushes the circumference. Therefore, the required derivative is dr dt multiplied by dc dr, which gives us dc dt. Dr dt is zero point 0.7, so we have 0.7 multiplied by dc dr, which is 2 pi. So we have dc dt as 1.4 pi. Since circumference it is only centimeter per second. This is the answer. So now next question is, the length of a rectangle is decreasing at the rate of 5 centimeter per minute. So time is given, x is there, y is there, again time is given. So we have dx dt equal to minus 5 centimeter per second, and dy dt equals 4 centimeter per second. We have to find the rate of change of perimeter and area when x is 8 and y is 6 centimeters. Fine. So perimeter equals 2 times x plus y. So the derivative of p with respect to time is dp dt equals 2 times dx dt plus dy dt, which equals 2 times minus 5 plus 4, which equals minus 2 centimeter. I'm sorry, here per minute, not per minute, per minute. So now what is the area? Area formula is length into breadth, x into y. So you need to use the product rule. So dA with respect to time is x times dy dx dy dt plus y times dx dt. Given x as 8 multiplied by dx dy dt as 4 plus y is 6 multiplied by dx dt is minus 5, which equals 32 minus 30 equal 2 centimeter per minute. So the area increasing at the rate of 2 centimeter per minute. So let's go to the next question. A balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeter. Here is the clue. Cubic centimeter means volume of gas per second, means time. So what we have been given is dV dt equals 900 centimeter cube per second. This is how you should infer from the question. Read the question like this only. Fine. Find the rate at which the radius of the balloon increases. So radius of the balloon. So that also to be the derivative of radius with respect to t. So we should find out dr dt because time is there. So spherical radius. So first of all, let us establish spherical volume equals 4 by 3 pi r cube. Our dv dr is 4 pi r square. Fine. So let us establish the chain rule. Time pushes radius, that pushes the volume. So we have dr dt multiplied by dv dr equals dv dt. What is dr dt? That we have to find out. So dr dt multiplied by dVdr is 4 pi r square. 4 pi r square equals dV dt, that is 900. Therefore, dr dt equals 900 into 1 over 4 pi r square, and when r is 15 centimeters, we have dr dt as 900 multiplied by 1 over 4 pi into 15 square. So 225 into 4 is 900. All this get cancelled. We have 1 over pi. This is radius, no? So 1 over pi centimeter per second. This is the answer. Next, a balloon which always remains spherical has variable radius. Find the rate at which volume is increasing with radius. Here, you see, very important, time is not given. So, you can differentiate, find the rate of volume with respect to radius and leave it. Fine. This is how we should solve this question. Time is not involved. V equals, this is spherical now, 4 over 3 pi r cube. So, dV dr equals 4 pi r square. Fine. So volume is increasing with respect to radius is 4 pi r square, and when r equals 10, we have 4 pi 10 square, which equals 400 pi centimeter square, volume, centimeter cube. Don't write second, minute, hour, because nothing has been given. 400 pi centimeter cube. That's all. So next question is, a ladder 5 meter long is leaning against a wall. Bottom of the ladder is pulled along the ground away from the wall. Yeah, it's a beautiful question. But the thing is, so far in all the questions, you have been given a geometrical figure. But in this question, especially, you are not given any geometrical figure, but you have to rather not assume, you should know what geometrical figure this represents. See, ground, wall, a ladder, it will make a right triangle. So we can have like this. This is ground, this is wall, and this is the ladder. Let us say, and more important thing, it is given in meters, 5 meter, here 4 meter, here centimeter. So very, very cautious. So make it as 500 centimeter ladder. And let us from the ground, it is rate of fall from the height. So let's say this as 400, and let's call it as x and call it as y. What are the other information we have? We have got, what we have got? Tx dy, rate of change with dx dt equals 2 centimeter per second. All these things are. So what will be y? So for the sake of simplicity, let's use Pythagorean theorem. So x square plus y square equals here 500 square. Let's take it as 5. Then we can add 0. 5 square, which is 25. So x square, we know it is 16 plus y square is 25. Y square is 9. Y is plus 9 plus 3 or minus 3. Minus 3 cannot be the length, therefore it is ruled out. So y can be 3. So now add 2 zeros, 300 centimeter. Fine. With this, how can we solve? Just take this equation, x square plus y square equals 25. Always very, very simple things. Don't complicate it much. Complicate much. So we derivate this equation with respect to time. Always time. Whenever you see time, only time and nothing else. So we have 2x dx dt plus 2y dy dt equals 0. So 2 is common. Take it out. X dx dt plus y dy dt equals 0, or x dx dt plus y dy dt equals 0. What you have to find here? How fast is the height on the wall is decreasing on the floor. So we have to find dy dt equals what? Because this in decrease only we have to find. Fine. So x is what? X is 400. Dx dt is 2. Y is 300. Dy dt we don't know, we have to find. Equals 0. Therefore, dy dt equals minus 800 over 300 or minus 8 over 3 centimeter per second. So the height of the wall with reference to the ladder is decreasing at the rate of 8 over 3 centimeter per second. That's all. So we'll go to the next question. A particle moves along the curve. Find the points on the curve in which y coordinates is changing 8 times as fast as x coordinate. Simple change and ratio. So we have to find, no, what has been given is we need dy dx equals 8 over 1. That's all. So both change with respect to time. So we have um, 6 dy dt equals, this is x cube plus 2, looks like x3, no, x cube plus 2 equals 3x square dx dt. Pull this dx dt here and take this 6 this side. We have dy dx equals 3x square over 6. This equals x square over 2, which should be equal to 8 over 1. So we have x square equals 16. This implies x equals plus or minus 4. When x is 4, so the equation is y equals x cube plus 2 over 6. When x is 4, y is 66 over 6 is 11, and when x is minus 4, this is 64, 62 minus 31 over 3. That's all. Next, the radius of, this is half an hour, half centimeter per second. I just want to correct, but I forgot. The radius of an air bubble is increasing at the rate of r, here time. So dr dt equals 1 by 2 centimeter per second. The rate of volume, then dv with respect to dt. V equal to 4 over 3 pi r cube. dv dr equals pi r square. So let's set the derivative. Time pushes radius, that pushes the volume. So we have dr dt multiplied by dv dr equals dv dt. dr dt is half, we know here it is here, 1 by 2 multiplied by dv dr pi 4 pi r square. It is 4 pi r square, which is 2 pi r square. When r is 1 centimeter, we have 2 pi, and since its volume, centimeter cube per second. That's all. Next question, 13. A balloon, always spherical, has a variable diameter. So d equals 3 over 2, 2x plus 1. So radius equals 3 over 4, 2x plus 1, because this is half of the diameter. No? So volume is 4 over 3 pi r cube. So important thing I will tell before that is, here the time factor is not there. So it's, if we find dv dx, that is enough. So simple. If time factor is not there, you can just try for other variables as per the needs of the question. So which equals 4 by 3 pi, you cube this, 3 over 4, 2x plus times 2x plus 1 the whole cube. This gives us 4 over 3 pi 3 cube over 4 cube times 2x plus 1 the whole cube. So cut it, we have 3 square, and cut it, we have 4 square. So 9 pi over 16 times 2x plus 1 cube. This is V. Therefore, dV dx equals 9 pi over 16 multiplied by 3 2x plus 1 the whole square. Since it's a composite function, again we have to find the derivative of d dx of 2x plus 1. This is 2. So we have dV dx equals 9 pi over 16 multiplied by 3 multiplied by 2 into 2x plus 1 the whole square. So this is 8. We have 27 pi over 8 times 2x plus 1 the whole square. This is the answer. We'll go to the next question. Beautiful question. Super hint in the question itself. Sand pouring from a pipe at the rate of centimeter cube. It means volume. Second, it means time. So they given dV dt equals 12 cubic centimeter per second. This is how we should identify the clues from the question. So word problem is very difficult, very easy. It's not at all difficult if you understand how to click at it. So fine, we got it. The falling suns form a cone on the ground. Fine. Height of the cone. Height equals 1/6 of radius. How fast the height of the sand of the cone increasing? So we want dh, whenever t is there, dh dt. That's all. Now, fine. Volume is involved. So what is volume of a cone? V equals 1 by 3 pi r square h. Since we want h, we will convert r into h. This implies 6h equals r. So volume equals 1 over 3 pi 6h square times h, which will get V equals 1 by 3 pi 36 h cube, or volume equals, this is not 12 times, 12 pi h cube. Therefore, dV dh equals 36 pi h square. Now, we will establish the chain rule. So, time pushes height, that pushes the volume. Therefore, we have dH dt multiplied by dV dH will give us dV dt. Fine. dV dH we know. This is 36 pi h square. dH dt we don't know. So dH dt multiplied by dV dH equal dV dt. What is dV dt? 12. Therefore, dH dt equals 12 over 36 pi h square. 3 times equals 1 over 3 pi h square. And we want to find when height is 4 centimeter. Fine. When h is 4 centimeter, we can put 1 over 3 pi 4 square, which is 1 over 48 pi. What is this height? So, centimeter per second. That's all. So, would I be enjoying this? Nothing, yeah, nothing. You got the concept, is nothing. So, this is what? Associated with the production of marginal cost. Whenever see marginal cost, find the derivative. It is very, very simple. Actually, it's a business math question. Fine. So we have to find sheet dash x equals 0.007 multiplied by 3 x square is put at 17 square minus 0.03 times 2 multiply x put 17 plus 15. So the remaining numerical part very easy. You please work it out. I don't want to spend much time. And so because nothing in it. Fine. So similarly this one also. Marginal revenue R dash x. So 26x plus 26. X put x is 7. That's all. You will get the answer. Next. Okay. Change of area of circle with respect to radius. Say nothing. Already we done with no. A equals pi r square. dA dr equals 2 pi r. When r is 6, we have 12 pi is the answer. Next, total revenue received. So given as Rx is 3x square plus 36x plus 5. No? So marginal revenue is what? R dash x, which is equal to 6x plus 36. The next we put 15. So you get the answer as 126. That's all. Hope you have enjoyed the entire video. So in the next week we will be dealing with exercise 6.2. Fine. Till then, take care. Bye bye. Leave your thoughts in the comment section.